Check, check, check. Well, good morning, everybody. Hope you had a great weekend. It's time to get back down to business. So today we are going to be discussing more about lines and graphing lines. Last class, I did mention that we are changing the schedule slightly. We are actually doing problems that, let's see, hold on. We skipped the scientific notation, imperial systems. So we are right here. We started with the intercept method from, well, that's what we did last time. And so we're going to continue that today. And then we are going to move into the next section, which is still graphing lines, but using a different method. So any questions before I begin? No? We're good? Okay. All right, so just recap real quick. Last time we were talking about linear equations with two variables in them, and how when you have a linear equation with two variables, you wind up getting lines when you graph all of the solutions. And so I said our task is going to be to try and graph a line, and there are two methods to do it. There are two methods. We started this first one called the intercept method. And this works as long as your line is not vertical or horizontal. This method will work to graph a line. So let's just pick up with an example. And let me see here. Let's do something easy first, just to remind us how to do it. And then we're going to do something with fractions. And then we're going to do something with decimals. That way we get a good feel for the different types of things we can see. So first one here, let's go with negative 4x plus 3y equals 20. And I want us to sketch this using the intercept method. All right, so who can remind me how to do this? The intercept method, how we do it.
You can start by, if you're going to find the x-intercept first, you sub in a 0 for y. If you're finding the y-intercept first, you set x equal to 0, and then you solve it.
Okay, good.
And that'll give you their intercept point.
Very good. So to find the x-intercept, what we'll always do is let y be 0 in the equation, and then we'll solve for x. So if I take this equation, negative 4x plus 3y equals 20, and replace the y with 0, then all I have is an equation with one variable in it, because the 3 times 0 goes away. And so you're left with negative 4x equals 20. And then you just solve this little equation by dividing both sides by -4. And you get x is equal to -5. So what that means is I have a point on my graph. I know the x coordinate is -5 and the y coordinate is 0. This is a point. Okay, so remember, all we need are 2 points to draw a line. We have one, all right? So let's go get the other one. So to do that, I'm going to find the y-intercept. And to do that, we let x be 0. So it's the opposite. You let x be 0 and then solve for y. So I rewrite the equation again. I replace the x with 0. I leave the y alone. And again, when we do this, the x term will go away, or the term that had the x in it will go away. And all we'll be left with is 3y equals 20. And then we divide both sides by 3. And we get y equals 20 over 3. Oops. Now, that answer, 20 over 3, is correct. That's the y-intercept, but we need to be able to graph it, right? So this is where you'd want to get your calculator out and get that as a decimal and get an approximate answer. And you know what? I actually was on campus yesterday and I found my old calculator. Did I bring it? Yeah, there it is. I knew I had one. I just wasn't sure where it was. It was in my office. So this is the calculator you're supposed to have for the class. All right, so let's do this. 20 divided by 3. Now, is anybody, when they type in 20 divided by 3, is anyone getting an answer where it just spits back 20 divided by 3 and it doesn't give you a decimal? No? Okay.
It gives me 6 point and then 6
Okay.
repeating.
6 points.
Man, mine too.
Okay, that's good. That's what it's supposed to do. Sometimes they set these up where it'll just spit back the same, like a fraction to you, like 20 over 3. And so, yeah, if that you're not getting that, no worries. The answer is about 6.66. I was just thinking about this yesterday. I don't know, this is weird. I was thinking about how in math, sometimes we come up with a number like 6.666 and like people freak out about, you know, 666. I don't know, I was just thinking about that yesterday and here we are, we have a problem happen right away. Okay, so about 6.66. This little equal sign, see how it's a little like squiggly equal sign? That means approximately, and that's a mathematical symbol. That's not something I'm just making up here. So anytime we want to say the answer is about something, we use a little squiggly equals. And that way we don't have to continue and write, you know, 6.66666 because it goes forever. And so we, you know. All right, so this as an x-intercept, as a y-intercept, x is 0 and the y is 6.66. And that's it. We have 2 points. We should be able to graph this. Okay, so now what I'm going to do is I'm going to draw my xy axes here. And let's start with the x-intercept. I go to the left 5. So 1, 2, 3, 4, 5, -5. And then here I'm going to put a dot. And then on the y-axis, I want to go up 6.6. So 1, 2, 3, 4, 5, 6. That's 6. Here's 7. So you have to approximate this, just eyeball it, okay? 6.66 is a little bit bigger than 6.5. So, you know, we're just trying to get it close. So what I'm going to want for you to do on your exam is I'm going to want you to label these points. That way, we're both sure that even if you graph the point in the wrong position, I know that you got at least the correct intercept. And now last step is just to connect these with a straight line. So I'll just try and draw a straight line here. Oh, straight enough. There we go. That's it. We talked about how last time the value of having the line graphed is, the line represents all the possible points that would be solutions to the original equation. So we could just look at this right now and know that, nothing, let's say over here would work, right? So like if you try and plug in, let's say 6, -4, that point is like over and down, right? To the right and down. That's a point over here. There's no way that this could be a solution to that equation. Okay, let's do one with fractions. Any questions? -2/3 x equals 5/12 y plus 3. Now, this is a linear equation with two variables still, right? We have the equal sign. It's an equation. It's linear because both variables are raised to the first power. Even though we don't write the 1, we have to understand that there is a 1 there. And so we have a linear equation in two variables. So we know that this is going to be a line. We want to sketch this. We want to use the intercept again method. Okay, now you could, right now, you could do what we did before. You could just plug in, find the x-intercept, plug in 0 for y. You could find the y-intercept by plugging 0 in for x. Or if you want, you can clear the fractions out to start. And that's kind of up to you. So I'll let you all decide. Do you want me to clear the fractions out, or do you want to just go straight to the method? And if we have to deal with fractions, we deal with fractions. What do you prefer? Any?
Clear out fractions.
Not fractions, John? Is that what you said?
Or I mean, clear out the fractions first.
You want to clear it? Okay, let's clear them. And then if people are really like, oh, I don't like that, then maybe we can do it the other way and just see the difference between the two ways. All right.
Okay.
So if I'm going to clear the fractions, what I have to do is I have to look at all the denominators, which I only have two denominators, 12 and 3. And I have to find the least common denominator. Now, we've done this before when we were working on equations with one variable. We have to look at all the multiples of 3, all the multiples of 12, and find the smallest one that is a multiple of both. So what would that be? What's the smallest? 3 goes into both, but that's not the smallest multiple of both of them. So 3 is not a multiple of 12. 12, did I hear 12?
Yeah.
Yeah, 12. So look, 3 does go into 12, right? 3 times 4. Okay, so 12 is a multiple of 3, and 12 is a multiple of 12. So you're looking for the smallest multiple of both. Has to be both. Any questions on that? Okay, so the thing is now, if our 12 is our kind of magic number, what do we do with it? Do you remember what we did in previous?
Don't we multiply 12
Multiply.
times 3?
Yeah,
And then
we're going to multiply both sides of the equation by 12. Both sides. What you do to one side, you have to do the other. So watch how I do this. I'm going to do 12 on the left side. So I'm going to do 12, and I'm going to multiply that times -2/3 x equals, then I'm going to multiply 12 on the right-hand side times whatever was over here, 5/12y plus 3. Now, on the left side, I only have one term, meaning I don't have addition or subtraction between anything. So that means all I have to do is really just multiply the 12 times the -2/3. I'm gonna do that on the side. 12 times -2/3. That's the same as 12/1 times -2/3. And we've done this before. We've done multiplication of fractions. We just go straight across. We can also reduce if we wanted to right now, like 3 goes into 12 4 times, but I'm just going to go straight across. This is negative 24 over 3. And that should turn into a nice number, negative 8. Because a negative divided by a positive is negative. So the number that's now in front of this x is now negative 8. And then don't forget, we still have the x there. See, no fractions, right? We've cleared the fraction out. Now on the right-hand side, any questions there? Right-hand side, here to here, same thing. We're gonna have to distribute because there's two terms. So when we go and we do the first one, we have to do 12 times 5/12. This one I'm gonna do a little faster. These 12s just cancel because that 12 is really like a 12 over 1. So all you'd be left with is the 5. So 5, and then don't forget the y. And then plus, now when you do the 12 times the 3, you should get 36. Okay, here we are. We have an equation. It's a linear equation in two variables. It's the same equation as before, just written in a different way. And so now we can go ahead and get the x and y intercepts. See, no more fractions. So if I get the x-intercept, what I'm going to do is rewrite the equation. And I'm going to replace the y with 0. So when I replace that y with 0, it goes away there. You get negative 8x equals 36. And then divide both sides by negative 8. And you'll need your calculator there again. So we'll get a decimal here, right? It's going to be approximate, well, it's exactly, negative 4.5. So now that means that I have an x-intercept, negative 4.5, 0. I now get the y-intercept by rewriting the equation again, but this time replacing the x with 0. When I replace the x with 0, the left side of the equation turns into 0. And then here we have 5y plus 36. Now we have to solve this for y, so we have to do a little bit of work here. I'm going to have to move the 36 to the other side, so I'm going to subtract it. And then I'll divide both sides by 5. And then again, you can use your calculator to get that. Ooh. 7.2, negative 7.2 is my y-intercept. And that means I have a point 0, negative 7.2. Any questions? Graph time. I'll go a little faster here. Just gonna draw it real fast. Okay, negative 4.50. That means I go to the left. 1, 2, 3, 4. Here's 5. That's negative 5. So negative 4.5 is about right here. And then I have negative 7.2. So 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. So negative 7.2 is a little bit past negative 7. Let me go ahead and label these points. And then draw a straight line between them. Are we good? Okay, let's say you didn't want to clear the fractions. Okay, let's just say that you started with this problem. I'm going to do it real quick over here. Let's say you had negative 2/3 x equals 5/12 y. I'm going very quick through this. let's say you had that and you said, I don't want to clear the fractions. Okay, so you do x-intercepts. So you replace the y with 0. So you get negative 2/3 x equals 5/12 times 0 plus 3. That goes away. So you're left with negative 2/3 x equals 3. Does anyone know what to do here to get x by itself?
You
See, 'cause we have a
divide by
fraction.
-2/3.
I'm sorry, say it again.
You divide by -2/3.
Yeah, you could divide both sides by negative 2/3. Now, if we do that, it'll go away over here, right? But over here, we have to take that and divide by negative 2/3. So here's what you would have to remember, that this really means 3 divided by negative 2/3. And then you'd have to remember that whole thing, keep dot flip. Remember that thing, keep dot flip? So we keep the 3, we change division to multiplication. So keep dot and then flip the other one over, 3/-2. And now we're going to multiply these. So I have to look at 3 as 3/1 and then just multiply straight across. If you do that, you should get 9/-2. And if you do that on your calculator, you will get -4.5, which is exactly what we got this way. So I'm not going to do the y-intercept. I just wanted to show you like it can be done this way. It's kind of up to you how you want to do that, okay?
So when we get to the part where it's negative 2/3 x equals 3, and you're dividing negative 2/3 on both sides.
Yes, just
Okay.
like over here, when we had the 8x or negative 8x, we divided both sides by -8 to get rid of the -8 in front of the x. Same exact thing, except we have to divide by a fraction to get rid of the fraction in front. And that just makes it kind of complicated on the right. I mean, it's not too complicated, but you just have to be careful. Like, what does this mean, right? You have to remember it means this, and then keep dot flip, and then multiply across. Okay, let's do the last one before we move on, and that's going to be an example where we have decimals. Okay, so let's say we have 3.4x minus 1.2y equals 5.6. All right, well, we have decimals, right? We may not like decimals, although having a calculator kind of makes it easy, I guess, easier. So I don't want to work with the decimals, okay? I don't feel like it. So what I'm going to do is try and get rid of them. And remember, to move a decimal point one place to the right, you have to multiply by 10, right? Anytime you multiply a number by 10, it moves the decimal to the right one place. So imagine if we multiplied both sides of this equation by 10. Then here, what's going to happen is that's going to become 34x minus 12y equals 56. And now you have an equation that you don't have decimals, and you can just go do what we did before, right? So if I want to find the x-intercepts, does anyone have a question on that step?
Yeah, where you got the 10, it was because you multiply or you moved the decimal point 1, right?
It's because I wanted to move it one place. See, I looked at all of these and I said, hey, if this moved once, it would be 34. This moves once, it would be 12. And if this moves once, it'd be 56. So I'm going to multiply by 10. Now, since you brought it up, what if I had this instead? .4, 1.25, and 5.6. If I move the decimal point one place over, it'll turn this to a 34, but it's only going to turn this into a 12.5. It's not going to make it a nice number. It's still going to be a decimal, right? And this, if I move it one place, will be 56. So moving one decimal point is not enough. I need to move it 2 decimal points over to make everything be nice numbers. So that means I'd really be multiplying not by 10, but by 100. Now, it's not important. That's not important. What's important is how many places you move the decimal. So we're going to move everything 2 places to the right. So this becomes 340x minus 125y equals 560. So everything moved 2 places. And they're big numbers, but at least they're not decimals, and you can go work that out, you know, the rest of the way. All right, can I leave that alone? I'll finish this one. Over here, I'm going to find the x-intercepts. So I set y equal to 0. And that gives me 34x equals 56. I divide both sides by 34, so 56 divided by 34. That's a weird decimal. 1.65. I'm only going to round it 2 decimal places. My calculator is saying 1.647058824, but I'm just going to say 1.65. Remember, we have to graph these, so it's not, we can't be that precise anyway. 1.6 or 1.7 would be fine. For the y-intercept, I set x equal to 0. So I get 34 times 0 minus 12y equals 56. And that gives me negative 12y equals 56. And I divide 56 by negative 12. And I get y is negative 4.666. So I'm, hey, it happened again. I'm going to say negative 4.67. And remember, these are points. I forgot to put here 1.650. And this one is 0, negative 4.67. Before I start drawing my graph, I always look to see how big these numbers are. Like I don't want to be like, you know, 1, 2, 3, 4. I don't want to make it that small because the biggest x value, or my x value for my x-intercept, is 1.65. And my y value here is negative 4.67. So I think as long as my window can cover like, you know, left and right 5, up and down 5, we should be okay. So what I'm going to do is just say like 1, 2, 3, 4. Okay, so 1.6. It's 1.650. And then negative 4.67. So I'm going to say this is negative 1, 2, 3, 4. Here's negative 5. So I go a little bit past 4.5. So somewhere around there. There we go. Okay, any questions? So this method for graphing a line, this intercept method, I said it only works if you do not have a vertical or horizontal line, right? So let's talk about vertical and horizontal lines, because that's kind of the exception right now that we haven't talked about how we graph those. So vertical lines, horizontal lines. I used to have a problem remembering which was which. It's kind of obvious once you think about it a little bit. Horizon, right? When you think about the horizon, if you know what the horizon is, right? The horizon is, you look out, say you're at the beach and you look out and you see the horizon where the sky meets the ground. Okay, that's your horizon. That's horizontal, right? Vertical would be up and down like this. So when we draw horizontal, let's start with vertical, sorry. If we draw a vertical line, right? Here is an example of a vertical line, right? Now, it can be anywhere though. So I have a little animation here for us. Let me bring this in here. So for a vertical line, it can be pretty much anywhere we want. I can position it anywhere, right? Any of these are vertical lines. In fact, you could have a vertical line that goes right through the y-axis. But the important thing is that it's vertical, right? So I'm just going to pick one. Let's say right there. Now, when you look at that line, I'm going to start moving. Do y'all see that 0.6, 2.3? Y'all see that point right there? That's a point on this graph. I'm going to start moving it up and down, and I want you to tell me what's changing when I move up and down.
Y-intercept.
The y value, right? The y value is changing. What stays the same the whole time?
The X value.
The x value, right? The x is always 6, isn't it? For this particular vertical line, the x value would always be 6. If I move it to somewhere else like that, like let's say I move it here, and now I start looking at all these points, what's staying the same here?
The X.
The x again, right? The x. That is actually the fundamental property of all vertical lines, is that once you have a line fixed in place, the x coordinate on that line is always the same. Always. It's the number, it's actually the number, this -7, is actually where this hits the x-axis, isn't it? But it's the same up and down the whole way. So when we go to do a vertical line, what we do is we try and figure out, okay, where does it hit here? We'll call that K. Okay, it's just some number, K. The equation of a vertical line is x equals K. That's it. X equals K. So let's go back to that picture I had. What would the equation of this line be? Oh, hold on. Can someone tell me what the equation of that line would be? Where's my program? Where is it?
X
Would it be-
equals -7?
X equals -7. Exactly. That's the equation of this vertical line. If you ever see an equation where it's x equals a number, that tells you we're talking about a vertical line. The reason why it's x equals that number is exactly that point that I made a minute ago, that no matter where you are on this vertical line, your x is always the same, right? -7, no matter where I am. So that means the equation should just be x is -7. And the y value is kind of free to be whatever you want it to be. Now, how do you think that's going to change if we talk about horizontal lines? So look at this blue horizontal line. If I start moving a point back and forth, what stays the same? What changes?
The Y
Y
stays
stays
the
the
same.
same.
Y
Stays the
stays the
same.
same, right? The y stays the same. So does it make sense to you that the equation of this line should be what? Y equals, this particular line should be what? Y equals what?
3.
3. Because no matter where you are on the line, the y value is always the same. So that's why we, when we say, you know, what is the equation of vertical line and horizontal line? That's why we do it. It's connected to the picture. So I need to go back to my other notes. So let me clear this out. And so if you have a vertical line, wherever it hits the x-axis, let's call that number K. X equals K will be the equation of that vertical line. If you have a horizontal line and you have, here's my horizontal line, and let's say it hits at some value, I'm going to actually call it B, then the equation would be y equals B. So I can give you real easy problems here now. Sketch. Let's do a couple of them. If I say sketch x equals 5, part B, x equals -3, part C, x equals 0, part D, y equals 4, y equals -5, oops, y equals 0. Okay, so I'm going to try and sketch these all together. I'm going to do it all on one graph. All right, it's been a while since I called on people, so let's go. Is Hallie here? Hallie?
Yeah.
Okay, Hallie.
out here.
Can you tell me, just tell me what I'm going to draw for part A.
So for A, you're gonna draw a vertical line.
Vertical line, and where should I
Yeah.
start it at? Or
Five.
where is it? Is it going to hit the x-axis or y-axis? It's a vertical line, right?
Gonna hit the x-axis
Okay, at
at the value of 5.
5 right there. So it's going to hit here and it's going to be vertical. There we go. That's this one, right? Okay, good. How about Chelsea?
I'm here.
Okay, Chelsea. So what do you have for part B?
The X will be on -3,
Okay, and I'm drawing what type of line?
a vertical line.
Vertical. Okay. Boy, that line doesn't look very vertical. That first one I drew, does it? Okay, Chelsea, sticking with you. How about part C?
It'll be on 0. The vertical.
Okay. And so straight up and down, right here from 0.
Yes.
What is another name for that line I just drew? Isn't that also the y-axis? Right?
Yes.
The y-axis is actually the same as x equals 0. So x equals 0 is equivalent to the y-axis. They're both vertical lines right through the middle, or right through the center of the graph.
So that means C and F would be the same, right?
Pardon me?
That means that C and F would be the same. X equals 0, Y equals 0.
Well, F is a little different because for C, we have a vertical line, right?
Well,
But
maybe
for F, it's horizontal. I don't know if that's what you meant. It's, it's going to be this way, right?
but it'd be in the same point.
It'll go through the same point. Yes, it'll go through here, but it'll be horizontal like this. So that'll be
Cool.
so this right here is the y-axis, right? And this one right here turns out to be the x-axis. Y equals 0 is the x-axis. Make sense, Joshua?
Yeah, that's what I meant. I think I just worded it
That's
wrong.
what I thought you meant. Okay. You were saying same point, like right here. They're going to
Yeah,
be going
Like
through
it
that.
goes the same thing.
Okay, y is 4. If we go up 4, draw a horizontal line. That's y is 4. And then y is -5 is down here. So would y'all agree that drawing vertical and horizontal lines is pretty simple as long as you can remember that x is vertical and y is horizontal? As long as you remember that, you're good.
Yeah, I'm chilling.
Okay. Questions? Questions? All right, we're going to move on now because remember I told you when it comes to linear equations in 2 variables, there's 2 different ways to do them. There's the intercept method. The intercept method does not work for vertical and horizontal lines, but that's okay because they're easy to draw anyway, right? So the next method is called the slope-intercept method. So this is the second method to sketch lines. It's called the slope intercept method. Now, to use this method requires that we have a little bit of an understanding of the way lines work. So the drawback to this method is that you have to have a little bit of a deeper understanding of the way lines work. The advantage of it is that if your line looks a certain way, if it's given to you a certain way, it makes it very easy to sketch quickly. You can do it very fast, but it has to look a certain way, which in most math class, like moving on into the other math classes, which y'all are not doing, but if you were, it would most likely be given to you in the form that we're about to see. So slope intercept method. So here's the idea. The idea is that, where is it? Here we go. The idea is this. If you have a line, okay, let's say you're looking at a line and you pick any 2 points on that line, all right? Any 2 points, doesn't matter where they are, okay? Any 2 points. Then if you wanted to try and get from one point to the next point, you're going to have to go up some amount and then over some amount to get to that point, right? We call this the rise. We call this the run, okay? So to get from one point to the other, you go up a certain amount and over a certain amount. Got it? Rise, over, run. Now, if I change the pitch of the line, if I change the pitch, that changes the rise over run, doesn't it? This is no longer the same, right? Now our rise is this much and our run is that much. So that's a different rise and run that we had before, right? So, but once you establish the line, I can continue using that same rise and run to get to another point, or I could even go backwards and down. So that rise and run stays consistent through the whole line. So long as the line is stuck and fixed, that rise and run will be the same throughout the whole line. Does that make sense? It doesn't matter where you start or stop. You can always use that rise and run to start moving from one point to the next. So let's act for a second like, for a second that I have a line here, okay? I'm not going to tell you anything about the line except this. I'm going to tell you that the line hits right here at 4. And then, so I've given you a point, right? Let's say I give you a point. Okay, I've given you a point. To draw the line, you only need one more point, right? Just one more. If you can just have one more point, you can draw me a line. So what if I give you this piece of information? Not only am I going to give you the point, I'm going to give you the rise and I'm going to give you the run. Would that be enough for you to draw me a new point now? If I tell you how to get to another point, by telling you how much to go up and over, would that be enough for you to do? Yeah, okay. So let me tell you, what if I tell you the rise is 3 and the run is 4? You know what, that's too much. Hold on. I want to be able to fit it on this graph. How about the rise is 2 and the run is 3? Let's do it that way. So that means from this point, to get to another point on this line, you would have to go up 2. Now be careful because this is 5 right here. So we're at 4. We have to go 5, 6, go up 2. And then run is going to be to the right. So we move 3 to the right. So careful, this is 1, here's 3. So we're going to go over 1, 2, we're going to go to here, that's 3, and we'll draw our dot right there. And then that would be it. You draw your line and you're done, right? Whoa. You should try and connect the 2 points together. There we go. Okay. So would you agree with this? If I give you 1 point on the graph, 1 point on the line, and I give you the rise and run, you're good to go? You should be able to draw it? Let me give you another one. What if I give you a point? Okay, here's the point I'm going to give you. 0, -3. And then I'm going to tell you that the rise is -2 and the run is 5. All right, so first thing we're going to do is let's figure out that first point that you were given. Right, I gave you this point, 0, -3. So I just go down, here's 0, -3. Everybody agree with that? Okay, how do I get to the next point?
You're gonna go down 2 and then
Down
right
2.
5.
Right, 5. So the rise was negative, right? I put -2 there. And that's to make sure you understand that when we talk about rise, if it's a positive number, then yeah, you go up. But if it's negative number, you're going to go down. And with the run, if it's a positive number, you go to the right. If it's a negative number, you go to the left. So I'm going to go from here. I'm going to go down 2, 1, 2. So I move down 2. And then right, how far did you say, John, to the right?
5.
5. So keep track. Here's 1, here's 3, here's 5. So I'm going to go 1, 2, 3, 4, 5 right there. And I draw another dot right there. So I went 5 this way. And okay.
Excuse me. Can you clarify again? I don't understand.
I'm sorry.
I don't understand.
Okay. What part don't you do you understand? I'm everything here in blue. I'm giving you this. Okay.
Okay.
And what I'm asking is, if I give you this information, can you draw me the line? So the first thing is I give you a point. You agree that this point right here in blue, that point comes from here, yes?
Yeah.
And then I'm telling you that to get to another point on the line, I'm going to provide you I'm giving you directions on how to get to the next point. The rise is going to tell you how far to go up or down, and the run is going to be how far to go left or right. So if I tell you to go rise by -2, that means from this blue point, starting here, go down 2, okay?
Okay.
And then I give you the run, which means now you need to go from there, you need to move to the right 5 units, and then that'll drop you right here.
Okay.
And then right there,
Sorry, wouldn't X be at negative, or Y, wouldn't it be at -5 then?
would what be a negative?
Because it's down 2.
Oh, we were at, yeah, why did I count it? Okay, I see your confusion now. This graph, this is my fault. This is my mistake. I'm happy to say I make a mistake. I didn't go down far enough. Is that why I was confusing you or no?
Yeah.
Yeah, because this is -3, right? That's
Okay.
-3. For some reason, I thought it was -2, but it's -2 right there. It's -3. So I need to go down 2. 1, 2. That's
Oh.
-5.
5, yeah.
There you go. Was that the part that was confusing you?
Yes, yes.
Yes. Okay. Yes. I'm glad that you brought it up. This is down 2. And then to the right 5. I'm going to have to erase this line. To the right 5. And I did get that right. So down 2 to the right 5, 1. I'm going to move me over here. And then the dot, connect those 2 dots. Thank you all for bringing that up. These tick marks, it skips unless I zoom in. And when we draw them on our own, we won't make that mistake because we'll be marking the ticks. We won't be skipping like that. Okay, are we good then? Everyone happy? So now I'm going to give you the equation of this line now. Okay, I'm gonna type it into the side over here and have the computer graph it. I already know what the equation is, so I'm gonna write it and then want you to see if you notice something. Oh, well, that's supposed to be the same line. Of course, my line's not perfectly straight. All right, can you all see this okay? I'm gonna write the equation down here for you a little bigger. Y equals -2/5 x minus 3. I graphed this equation on the computer and it's exactly the line that we just drew. Please recognize that these things are not a coincidence. This -2 here is the actual rise. The 5 here is the run. And the -3 is this y-intercept. So that's not a coincidence. That is a property of all lines, that if you can get them written in a certain form, then the numbers will tell you everything you need to know to graph it. All right. But we have to make it look a certain way. Let me give you that formula, and then we'll come back and do some more of this. So the slope-intercept method. If you're given the equation of the line in this form, y equals some number m x plus b. In other words, let's say you're given the equation of a line. Basically, when you look at that, notice that what it is it's just solve for y. Right? This is the general form of a linear equation. We have an equal sign, we have x and y in here. This m here is going to be some number, and this b here is going to be a number. Anytime you have an equation written in this form, that is called the slope-intercept form. The m will always be your rise over run, and the b will always be equal to your y-intercept. So in the problem that I had just done, as an example, I had given you y equals, or I had written and typed in the computer -2/5 x minus 3. By looking at this, I can just see right away that the rise is -2, the run was 5, and the y-intercept was -3. And from that information, we could draw the picture. So let's see if this makes sense. I'm going to do an example now, a new example. Let's see how we handle it. All right. So let's sketch this using the slope-intercept method. All right, y equals 3/5 x minus 4. Okay, Adriana, are you here?
Yes,
Are you following me or no?
yes, sir.
Okay, so Adriana, let me ask you first, is this written in this form? Does it look like this?
Yes.
Okay, so the m the M is the number in front of X, right?
Mhm.
And that for us is what number?
3/5.
3/5, okay, and I'm very careful here. What about the B? What's B for us?
-4.
-4. Everyone hear that? -4. You have to include the negative in there. So, Adriana, then tell me what the rise is. And tell me what the
3.
run is. The rise is 3.
And
So
then
that means
the
you're
run
gonna go
is 5.
up, right? You're gonna
Yes.
up 3, okay, and then the run is what?
5.
5, okay, so you're gonna go to the left or right?
The right.
Right, 5, okay, so that's great. Adriana knows that once we have a point, we can just go up 3/5. But Adriana, where's that point gonna come from? What piece of information have I not figured out yet?
The
What's this number?
the Y.
That's the y-intercept, right? So the y-intercept is -4. With me, Adriana?
Yes.
Everyone with me? That's it. Once I have that information, I can graph it because Adriana, we're going to go here and we're going to start with the only point that we know, right? Which is that y-intercept. And it was at -4. So I'm just going to go down 4. 1, 2, 3, 4. There's -4. And I'm going to put a dot here. That point is on my graph because it's a y-intercept. Now, Riley, are you here?
Yes,
Okay, so Riley, are you following?
yes.
Okay, so tell me how I'm gonna get to another point from that point.
You're gonna go up 3 and then to
Okay.
the right 5.
To the right 5. I'm gonna need to go to the right 5. So how about we do this? 1, 2, 3, 4, 5. There's 5. So I'm gonna go up. You said up 3 from here?
Yes,
Okay, so let me see. I'm just gonna jump 1, 2, 3, and then from there to the right 1, 2, 3, 4, 5, and right there I will drop a dot and then connect with the straight line. Here it is. Okay. Next one. Joshua, you here? Joshua T.
Yes, sir.
Okay. All right, how about this one?
Y
you
equals
tell me-
-3x plus 7.
Yep. We're gonna need the rise, the run,
And the run, right? Rise over run.
and the y-intercept, right? Those are the 3 things we're gonna need. So Joshua, is this written in the correct form? Is it some number in front of x plus a number?
Mx plus b. Yes.
Yeah, so this is this, right? And then the +7 is the b.
Is the
yes?
b. Yes,
Okay.
sir.
So I think you know what the y-intercept is, right? Is that
Plus b.
y-intercept will always be that number there at the end. So what is our
Mhm.
y-intercept?
7.
7. Okay, that one should be the easy part. The rise and the run can be a little challenging sometimes. Like in this problem, it's not as obvious because it's -3, right?
Yeah, I'm gonna say.
But do you agree that -3 could be rewritten as -3/1?
Yes, and it's an invisible one.
Yes.
Yeah, is an invisible one underneath everything. So if we do that, Joshua, then what would our rise be?
The -3.
All right, so that means we're actually gonna go down, aren't we?
Mm-hmm.
And then what would our run be?
The run is just 1.
1, and that means to the right. So you see that anytime you would have a nice whole number there, just put it over 1 and you're in business, okay?
So
We
now
go-
with the graph, you just put the 7 on the
Yeah.
graph, and
On
you
the
just go down
y-axis.
3 over 1.
Yeah. 1, 2, 3, 4, 5, 6, 7. There's my y-intercept. Now I just go, you said what, down 3 and over 1? 1,
Mm-hmm.
2, 3, and then to the right, 1, drop a dot. And
And so on and so on.
that's it. Yeah, you only need one other point, but you could from that point go down 3 and over 1 again. You could keep repeating that if you wanted to. So if you do a couple of these, you start getting used to it and you start to realize, wow, it's like really quick and easy to graph these. But the key is you have to have it in this form. If it's not in that form, you can't do it. So let me give you a problem that's not in that form. Okay, how about this? 4x. Well, you know what? Let's start with one of the first problems we did today. How about this one? Let's do that one. Let's see, is this method good for this or not? Well, it's obviously not in the correct form. Do you all
Wouldn't
agree?
you just like transfer over the 4, -4, and make it a positive or something like that?
Well, in order to use this method that we have to basically get it solved for y. We have to get y by itself on one
Oh,
side.
yeah.
Of the equation. If we can do that, we're in business. So I'm going to do that. I'm going to try and get this y by itself. So I'm going to add 4x to both sides. So that gives me 3y equals, now over here, I'm going to get 20 plus 4x, but I'm going to write it this way, 4x plus 20. The reason why I put the x in front of the 20 is because I'm trying to get it to look like this kind of. One more step.
Division.
Division, good. Divide everything by 3, everything. So you're going to get y here. Okay, 4 over 3x. I'm going to write that as 4 over 3x. I'm not upset to see this because remember this 4 over 3
Because
is
it's your
my
rise or
rise
the
and my
run,
run,
right?
right? So that I'm okay with. Now the 20 over 3, that's not that great because that's a decimal, right?
Yeah.
That goes in there like 6 point what?
6, 6.
That's the third
Yeah.
time it's happened today. I'm not even doing this intentionally.
It's a
Okay.
bad omen.
It's a bad omen right now.
Or for some
Okay.
people, it could be considered lucky. It just depends on your beliefs
Yeah, yeah,
Either way, it's an omen.
yeah.
of some
For some
kind.
people it's bad. For some people, they don't care. All right. I hope that me writing 666 doesn't ruin your day. Okay, here we go. So I'm going to try this. The y-intercept, right? I have a rise, I have a run, and I have a y-intercept. Okay, the y-intercept is 6.66. That's kind of weird. 1, 2, 3, 4, 5, 6, 7, 8. Here's 6. 6.6 is like, you're going to have to eyeball this. It's not going to be perfect. In fact, where's my cursor? You know what? I'm going to need to move this graph down a little bit. I'm going to need a little more room. Okay, so 6.6, I don't know. I'm just going to eyeball it about right there. From there, I have to do a rise of 4 and a run of 3. So that's up 4 to the right 3. So y'all see it's going to be kind of hard to figure out where we are because we're not on one of these tick marks. We're in between them. So we're just going to have to be careful about how we count. We have to go up 4. So 1, 2, 3, 4, and then to the right 3, 1, 2, 3, and put it here, and there we go. This method is just for quick sketching. Okay, it's to get a quick idea of what's going on. Questions? Okay, let's talk about if you have this Okay, if you have that form, how does this impact the picture, the graph of the actual line? So how does M control what the line looks like? And I'm going to show you with an animation here. So where is it? Okay, let me see here. So we have this line. Let me take some of these points and stuff off. Okay, we have this generic line right here. And notice I put on the computer, hey, let's graph y equals mx plus b. And I'm allowed to control the b and the m. So if I change the b is the y-intercept, isn't it? The b is the y-intercept. So if I change the b, what's going to happen to the line is it's going to move it up and down. Right now the line is hitting right there. Okay, it's hitting here. But if I adjust the b, now it's, notice the line has the same pitch to it, but now you're hitting here. See? So moving b around, all it does is moves the graph up and down. That's it. Now the m, watch what happens with the m. Right now m is 3.5, so this is a positive number. And the bigger it gets, the bigger the number gets, the steeper the line gets. And if I go and I make it a small number, it starts to flatten out. When I get to 0, it becomes horizontal. And then when I go negative, it starts to pitch the line the other way. So that is something we need to understand about lines. If the slope is a positive number, it's going to be kind of like going up from left to right. As you were to read, like if you read this like a book, from left to right, it's going up. That's if the slope was a positive number. If the slope was a negative number, it's going to be pitched down from left to right. Now, there's something about the slope that kind of gets by people here. And that is, no matter how you move, watch my M here. I'm going to make it a huge number. Okay, right now my M is 50. See, it's very steep, very steep. If I try and go, I'm going to go M, I'm going to take it all the way to 1,000. When I take it to 1,000, even at 1,000, do you see that it looks like it's vertical? It's not quite vertical though. There's a little gap. I'd have to zoom out here. There's a little gap there. It's hard to see it. Let me see if I go up here. There's a gap. Even, yeah, you can see the gap there. So even with the slope of 1,000, it's got a little bit of a tilt to it. Do y'all understand that? And if I went to 1,000,000, it would still have, it would be even steeper, but just a little bit of a tilt. It is impossible. There's no M that I could put in to get vertical. There's no M. So a lot of people think that, I don't know what people think, but I think a lot of people think that the bigger M gets, it just starts to pitch up and then it eventually like flips over. But no, the bigger M gets, it just gets closer and closer and closer and closer to vertical without ever actually getting there. And if you go negative, then it pitches the other way down. So, and the same thing, big negative numbers will try and get it vertical the other way. So let's just wrap that up. I'm just going to state this and then we'll talk about the homework. So if you have a line like this, here M was a positive number. And if the line pitches down like that, then that means your M is a negative number. Right, M being greater than 0 means positive, and M being less than 0 means negative. Okay, when we come back next time, which would be Thursday, right, we will talk about parallel perpendicular lines, and then eventually we're going to start doing some applications. You know, where do we see lines show up in the real world? We're going to do some word problems. You know, if you have a job and you get paid hourly, if you clock in and clock out, then you're dealing with linear functions every day, linear equations, because you can determine how much money you'll make or how many hours you need to work to make a certain amount of money. Or if you pay any bills like electricity or water, then there's linear equations involved in those things. So we'll do some applications that'll at least maybe make some of this feel worthwhile to you. In terms of, excuse me?
I had a question real quick.
Yes.
So for whenever you're changing, whenever we are looking at it, the y equals mx plus b, and it changes the pitch, that kind of reminds me of like when you're using a table saw, because you can change the pitch wherever you're cutting wood, if you're going to put it along the wall, or if you're going to join the wood together. That's what it reminded me of, like how you're changing the
it is. I mean, that's, now with that, we're using angles, right? We're using angles. And so when you talk about an angle, you have like 0, you have like 30 degrees, 45 degrees, 60, 90. When we talk about the pitch of a line, the m, that slope is not a degree measurement. It's a ratio. It's telling you the rise divided by run. And yeah, the reason you can't have a vertical line, I'm getting off topic here, but it's on topic. The reason you can't have a vertical line, well, you can have a vertical line, but you can't talk about the slope. Okay, if I ask you to figure out, like if you were at this point right here, and I said, hey, get to another point on this line, then your rise is going to be something, right? Your rise will be a number. But what's your run going to be? What's your left and right going to be? Nothing, right? 0. So when you try and put rise over the run, because that's what the slope is, then you're going to have a number divided by 0, and that's undefined. So if somebody were to ask you, what is the slope of a vertical line? Your answer would be, it is undefined. A vertical line does not have a slope. Now, if you say, what slope of a horizontal line? That's 0. That's a 0 slope. Okay, so for homework, let me make sure I get to the right. Last time I asked you to do, let me get to it here, homework. I asked you to do like, you should be able to do, why don't you just try page 65, 66, 67, 68. Yeah, just try 65 through 68. Some of the questions are going to be weird questions because we really didn't talk specifically about them, but they're more like idea questions, like, do you understand the concept? Like it'll ask like, how many points do you need to define a line? Something like that. Okay, so it's not something we like formally did, but we've talked about. So just try that for homework. And then that's mostly stuff from last time. The other stuff, get to it here, homework. Page 75. Yeah, just do on page 75, 1 through 6. So on those, just be careful. What you're going to have to do on those is first get them all solved for y. So you have to take each of those equations, move everything over to get y by itself, and then use what we learned today with the rise, run, y-intercept thing. But you have to get everything moved over first. So see how it goes. We'll come back on Thursday. I'll answer questions. Y'all have a great day. Does anybody need, anyone need?
you.
Thank you.
So I know
Thank
you were